How's it going? I'm David King, and my part of the group project was uniform distribution. So, what is a uniform distribution? A uniform distribution is a distribution that occurs when there are multiple outcomes, with each outcome having the same probability. The support of a uniform distribution is going to be the interval between A and B, and that is going to be for a continuous distribution only. We will touch on discrete distributions in a little bit. So the upper bound is just going to be B right there. You can see that the upper bound is simply going to be a straight line right at our upper bound, and then the lower bound, A, which is where we're going to start the sample space, is going to also just be a straight vertical line right at our lower bound. So within the interval A and B, the probability density function is going to be as follows. In plain English, that simply means that the probability of x being any outcome within the interval A and B is going to be 1 divided by the number of outcomes here. And the probability of x being any outcome outside of A and B is just going to be 0, of course. So, an example, this is now going to be a discrete distribution, winning the Powerball. In order to model the probability of any one player winning the Powerball jackpot, we will make the following assumptions. Number 1, each player has entered the Powerball drawing exactly once. No two players have the same numbers. No power plays or any other modifiers are being played. And this drawing has exactly one winner. As this situation has distinct outcomes, we are working with a discrete uniform distribution. So here is a uniform distribution with a discrete distribution right here on the left. So we can see this function models the probability of any one player winning. As you can see, there's multiple distinct outcomes there, given the stipulations that we listed on the previous slide. As this is a discrete distribution, the support is going to be P1 through 10. As you can see, we couldn't simply put, for example, like we couldn't simply put an interval like we couldn't simply do P1, P10, as that would imply all of these outcomes between, which of course you can't split people into a continuous distribution. That would probably be a war crime. So of course we are just going to have these distinct outcomes right here with the individual distinct players, and the parameter is simply going to be a lower bound of P1 and an upper bound of P10. So that includes both P1 and P10, but nothing outside of it, and every outcome within it. As we can see, the function definition is simply a straight line. If we added more players, the line would remain horizontal, but move closer and closer to 0 as the number of players increased. Spoiler alert, it is practically at 0 in real life. It is never a good idea to play the lottery. So, with 1,000 players, we can see how quickly this graph becomes very, very dense. And the chances of any one player winning decreases dramatically. Each additional player increases the spread of the distribution, lowering the probability of any other player winning proportionally. And as with any other uniform distribution, the center is always just going to be, P1000 plus 1, and then divided by 2, so your center would be at 500.5. So that would just be your center right there. And then, as always, we have a lower bound of P1 and an upper bound of